Okay, so in this video we're just going to be looking at more proofs for real numbers, but we're looking at the irrationality of numbers like, for instance, square root of 2 or log 2 5, and we're going to use the contradiction approach. And again, you've had some practice on these, but we'll have more practice. I'll find some. Okay, so what we're looking for in a contradiction is we need to prove the opposite statement. We need to start with an opposite statement and then prove an irrationality. So if root 2 is irrational, the opposite statement is root 2 is rational. And what rational means is, again, that it can be expressed as, it can be written as something over something, and that is cancelled down to its lowest terms. So, lowest. Like, for instance, 2 over 4 is not cancelled down because they're both even numbers, and that's what we're going to be looking at. We're going to be proving that both numbers are still even. Okay, so we start off with the opposite statement, and so the opposite statement is this, and we'll prove the irrationality of that statement. So the first thing you do is you square both sides, so you end up with a squared over b squared, and then cross multiply. Now, because there's a 2 there, we can say straight away that a squared must be even. And if a squared's even, we've seen that before, that a must be even. Okay, so let's keep going. I'll change colours. So, if a is even, then a can be written as 2 times some other number. Okay, so if something's even, we say it's 2 times something else. So that means that 2b squared, back here, 2b squared equals 2k all squared, because it's a squared. 2k all squared is 4k squared, and that's 2b squared. And then divide both sides by 2, so b squared equals 2k squared. And then we've got this 2 again, so that means that b squared is an even number, which means that b is an even number. So we've got a is an even, b is an even, and that's the contradiction. So the contradiction is they can't both be even. Cannot both be even. So if there's a contradiction in that statement there, then that means that square root of 2 is irrational. Okay, so copy that down, and when you're ready, come across the next slide. Okay, so the second one that you have to look at are to do with logarithms. Okay, so what we have to prove is that log 2 5 is irrational, and again we start off with the opposite statement. We say that log 2 5 is irrational. So this time it's a slightly different setup. So we've got log 2 5 equals a over b, which is what we're saying is the opposite, and then this answer here is the index to that base. So we can say that 2 to the power of a over b equals 5, and then to show the proper setting out, we raise both sides to the power of b, and what that does is the b's cancel out, so we end up with 2 to the a equals 5 to the b. And the question is, where is the contradiction? Well, if you look at the left hand side, which is 2 to the a, which must be even, because any number 2 to any power, it will always be an even number. But on the right hand side, which is 5 to the b, 5 is an odd number to any power is an odd. Okay, now it's not where you've got an even over an even, but if one side is even and the other side is odd, they can't be equal to each other. Okay, you can't have an even number equals an odd number, so therefore we have a contradiction in the statements at the start, and so therefore at the start log 2 5 is irrational. Okay, and that's the end. So there'll be practice on these sort of questions, but that's basically it. Thanks for coming.